So in this video we will understand about the quantum mechanics, the development of quantum mechanics, and Bohr model, and then discovery of the dual nature of the electron, quantum mechanics. So Niels Bohr has given the first time about this quantum mechanics theory, and according to that, so Niels Bohr adopted Planck's assumption and explained these phenomena in this way, that only orbit of certain radii corresponding to specific energies are permitted for the electron in a hydrogen atom. So mainly Bohr model try to explain the spectrum line spectrum of hydrogen, and he said that there are certain radii, there are certain orbits, they have fixed radii, and corresponding to the specific energies are permitted for the electrons in the hydrogen atom. So the hydrogen has one electron, and this electron have certain orbits. There are fixed some orbits are there, and they have certain radii. So for example, this is one radii, this is another orbit, this is the one orbit, this is the another orbit, and electron is moving in this orbit, and it can and are permitted to electron in permitted for the electron in a hydrogen atom. So they are permitted in a fixed orbits. For an example, here and this spectrum, this figure shows that if electron is in this level, it can go up or it can go down. So let's see the next postulate of Niels theory. An electron is permitted orbit is in an allowed energy state. An electron in allowed energy state does not radiate energy and therefore does not spiral into nucleus. So basically, in nucleus is positively charged, and electron are circulating in a certain orbit in case of hydrogen, and this electron, when it circulate or when it move around the nucleus, it do not lose the energy. If it will keep losing the energy, ultimately it will go and mix in the orbit in the nucleus. So they do not lose the energy according to Niels Bohr, and energy is emitted or absorbed by the electron only as the electron changes from one energy state to another. This energy is emitter of the absorbed. This energy is emitter of absorbed as photon that has the energy E is equal to h nu. So, and if they are moving into different orbit, they can either absorb the energy or they can emit the energy, and that can be calculated with this equation, which is E is equal to h nu, where h is a Planck constant and nu is frequency of the. So this next is this slide. So Bohr model said that electrons in the lowest energy state are in the ground state, and any energy higher is called an excited state. So according to previous slide, if you see this one, so if electron is at this energy level and it can go up, then it will be excited state, and it need to absorb some energy, then it can go in the excited state, and when it will come back on the ground state, it will lose the energy. So any energy higher is called an excited state, and using this equation we can find out what will be the difference in energy level. So this picture shows that when the electron move from one energy level to another, and how much energy is required, or when it come back from higher energy to lower, how much energy will release. So right now it is not important to memorize, or you because there is no, we are not going to use this equation in this chapter, but it is very important to know that electrons have, when they have minimum energy level, that is called ground state, and when they go into the higher energy state, it's called excited state. And what do the value means using the Bohr model? A positive delta E means energy is absorbed. A photon is absorbed in this instant, so this will happen. Small n is equal to small n is final is more than small n is initial. So when electron goes from the ground state, which have the lowest energy, to the excited state like number 2, number 3, number 4, number 5, or in any higher energy level than the 4, then it absorbs the energy. And how we will find out? So it will be delta E will be n final, energy of the final state minus energy of lower state. And when the electron will come from the excited state to ground level, they releases the energy, so the delta E will be the negative in this case. So let's summarize a little bit once again this Bohr model. So according to Bohr model, they said that energy is required to move an electron to a higher energy state, which is called excited state, or any higher energy state of the atom. So this is a model which shows that dark spot is a nucleus, and this electron, when moved from one energy level, this is the closest one, which is the nearest, which is have the lowest energy, to the higher energy level, energy is required to this electron to move from ground state to higher state or excited state. And energy is given off as the electron move to a lower energy state. When the electron come back to its own ground state, energy releases. So it's exactly same amount of energy required, which comes out from the same number of transition state. So what Bohr model explain? So Bohr model explain the line spectrum of hydrogen. Electron in an atom exists in a stationary state called orbit or shell. The orbit correspond to small n, which is equal to 1, 2, 3, 4, or also designate as KLMN. An electron remain in their orbit without emitting electromagnetic radiation or energy, therefore does not spiral into nucleus. So whenever the electron move into the orbit, they do not emit any energy, otherwise they will keep losing the energy and will do spiral motion, and then at the end they will neutralize by the nucleus, they will go into the nucleus, which is not true. So transmission of electron between the stationary state produces or absorb the electromagnetic radiation. So if they are going to higher state, they need the energy, and if they are coming back, they are losing the energy. So the energy absorbed is or lost is equal to the difference between the energies of the two energy level, which is delta E is equal to E higher minus E lower. So this was the Niels Bohr quantum mechanics model to explain the hydrogen line spectrum of hydrogen. But there are the limitation about the Bohr model, that it works only for the hydrogen, and classical physics would result in an electron failing into positive charge nucleus, but Bohr simply assumed that it would not. So this was the main problem. And then circular motion is not like wave in nature. So according to Bohr model, they said that this electron will keep moving in an orbit. So this circular motion is not wave like in nature, but electron shows the wave like nature. Therefore this Bohr model applied only for hydrogen and not for any other elements. But there was some key important points were taken and applied in the modern atomic model nuclei. So points that are incorporated into current atomic model include the following: electrons exist only in certain discrete energy levels, which are described as quantum number. So for an example, if this electron is in number 1, shell number 1, that is called quantum number. So quantum number 1, which is represented by small n, quantum number 1, this one, and then this will be quantum number 2, and they have discrete energy level, means fixed energy level, and energy is involved in the transition of an electron from one level to another. So these 2 points were considered when modern atomic theory or modern quantum mechanics theory was established. And based on these quantum mechanics, the another scientist which is Louis de Broglie theorized that if light can have material properties, it means matter would also exhibit as a wave properties, and he demonstrated that the relationship between the mass and the wavelength was lambda is equal to h upon mv. So probably this equation is also important for you to memorize, that if light can behave like a material property, then matter could also behave like a wave property. So lambda is a wavelength which is represent for the wave, and small m is a mass. Mass is for matter. And based on these two theories, Bohr's theory and de Broglie's theory, the wave nature of the light is used to produce this electron micrograph. So electron microscopy was developed based on the quantum mechanics. So this was the initial startup about the quantum mechanics. And then there was one more scientist, Heisenberg, gave the uncertainty principle, showed that the more precisely of the momentum of the particle is known, the less precisely its position is known. So it says that if we do not know the more precisely momentum of the particle is known, the less precisely its position is known. So basically uncertainty principle says that the position of electron is very uncertain. It can be any place at a moment, and he established this equation which is called the uncertainty principle. And from here the quantum mechanics came. And in quantum mechanics, Erwin Schrödinger have developed the mathematical treatment into which both the wave and the particle nature of matter could be incorporated. This is known as quantum mechanics. So quantum mechanics is nothing but how to express and how to present, how to explain the wave and particle nature, dual nature of electron, and that is the quantum mechanics, where Schrödinger has given mathematical expression, mathematical equations to explain the wave nature and particle nature of the matter, which was called the quantum mechanics. So according to quantum mechanics, the solution of Schrödinger wave equation for the hydrogen yield wave function for the electron. The square of the wave function given the electron density or probability of the where an electron is likely to be at any given time. So he presented a mathematical equation, and based on that we can calculate that what will be the probability of finding the electron at a particular place, because it's not very fixed that where the electron will be there. So high dot density is high function wave, this is called wave function value, high probability of the finding electron in this region, and low dot density means low probability of finding the electron. So wherever the dark blue color is there, it means the density of finding the electron will be more here compared to the outside. So this these theories basically are developing to explain the quantum mechanics is explaining how the electron behave like a wave and particle, and how we can find its position at certain time. So we will see more about the quantum mechanics in the next video.